Good afternoon. I am Navinya Shende. I am Senior Principal Software Engineer at Red Hat. I have more than 10 years of experience in product development. We are supposed to have my co-speaker Tarique Aman Aziz with us, but he couldn't join us due to some unfortunate event. So without further ado, let's get started. As the title of the talk suggests, Diagrams as a Code, Decoding Architectural Diagrams. This talk is about moving from static, outdated pictures to dynamic, sustainable architectural blueprints. My goal by the end of session today is for you to walk away with actionable insights that you can apply immediately to your projects to make your designs clearer, your collaboration smoother, and ultimately your software projects more successful. So let's take a look at what all topics we will be covering today. Think of this as an architecture diagram for our talk. So first, we will start by understanding the core need of architectural diagrams, then confronting the frustration of manual, traditional diagramming methods, and finally we will pivot to diagram as a code, which is a more modern, powerful technique for diagramming, which will help you make your software projects more successful. We will first establish the why part. Why do we need architecture diagrams in first place? Why are they so crucial in the modern software systems? Then we will take a look at how you can create effective diagrams. Then we will move on to the confronting the challenges of traditional diagramming methods. Next one then we will pivot to diagram as a code 1.0, which is a revolution in which brought revolution in creating architecture diagrams using text. Then we will take a look at more modern approaches of diagram as a code 2.0, which evolved from diagram as code 1.0. Integral to the diagram as code 2.0 is the C4 model, which we need to understand in order to start with diagram as code. So we will dive into the C4 model. Finally, we will have comparison between various tools that are available today to create diagram as code. So let's start. So how many of you are able to understand or at least get some context out of this diagram? Yeah, cool. So to kick things off, we will start with a well-known adage that is, a picture is worth 1,000 words. This is not a catchy phrase, but why we are here today and fundamentally how our brains work. Human mind has been designed to analyze and understand images far more effectively than the large textual blocks of information. When presented with a choice between a complex software workflow versus a lengthy description of the process, which one would you choose? I think most of the people would go for a pictorial representation of the complex workflow. For those of you who are here, if you are an entry-level software engineer trying to understand a system, or whether you are a mid-level engineer trying to design system, you are here to understand the clarity and communication in software design. Then so let's try to understand the modern era of software systems. Earlier, software systems were simple programs that were used for calculations. Now, with the advent of technology, softwares have evolved into more complex interconnected networks of systems. An organization might have dozens or even hundreds of services that might be interacting with together to deliver a complex functionality. With such inherent complexity, it becomes difficult to get a bird's eye view or 1,000-foot view of the entire system. Whether you are a new team member or onboarding to a team, or sometimes even experienced engineers find it difficult to get the complete overview of the system in their mind. For this, we need architectural diagrams. Then to navigate the system complexities, architectural diagrams can help us get that 1,000-foot view or bird's eye view of the system. Architectural diagrams can be crafted to present a clear and concise visual representation of the system. It can also be tailored to communicate to your audiences effectively. So, as developers, it's a difficult job to understand the entire system. Think about how your non-developers, how difficult it might be for them to just read through a lot of documentation and gain that understanding of the system. It might be your project managers, it might be your business analysts, it might be your even your clients who are trying to gain the understanding of your system, what functionalities it delivers, without actually diving into the code. So with architecture diagrams, you can tailor that communication as per the audience needs. You can only represent the specific part that you want to communicate to that audience. So architecture diagrams are crucial in this, and thus they make a foundational tool for bringing the clarity into your system. Next, so we all agree that architecture diagrams are important, but not just any diagram. We need effective diagrams that truly help to move your project forward rather than hinder the progress of the project. That brings us to what I call as minimal, meaningful, and consistent mantra. First one is minimal. Often I see people trying to add too much detail into a one diagram. What this does is it moves away the diagram from its serving its specific purpose. You can ruthlessly remove anything that doesn't serve a specific purpose of the diagram. If your diagram takes more than 10 seconds to read, it's probably too busy. Second one is meaningful. So what I mean by meaningful is every diagram should answer a specific question. Is it created to answer or to show the interaction between the users of the system, or does it describe the flow of data throughout your system? Don't make audience or don't make people guess what's the purpose of this diagram. You can label it clearly and ensure that it conveys real value to the intended audience. Third one is consistency. And what I mean by consistency is you should always use uniform notations, shapes, symbols, and colors whenever you are creating architecture diagram across a project or even across an organization. What this helps us with is building a clear understanding of the system. For everyone who is seeing the same things repeatedly represented in the same way, it helps them to build a visual understanding and a shared visual understanding of that. And it also helps to reduce cognitive overload. Then the ultimate goal of applying this mantra is to foster to bring true clarity and consensus among all the stakeholders of the project. When everyone sees the same thing in the same way, misunderstandings are minimized and alignment on design decisions are improved dramatically. So we understand that architecture diagrams are important, and we also took a look at how you can create effective architecture diagrams. Now let's be honest. The current pain point for most of the teams is the traditional manual architecture diagrams. May it be on whiteboard, may it be something like a paint image, a PNG that is created using tools like Excalibur, right? It's hard to create those diagrams. How many of you have seen an architecture diagram that was updated more than over 3 years ago, right? Yeah. It's a common scenario. Manual diagramming is inherently time consuming. You have to drag and drop the shapes, connect those arrows, align the text, and this all adds up if you have a specifically complex software system. The manual effort often means that diagrams are always created at the start of the project and then rarely touched again. This idea leads directly to the biggest problems. Diagrams quickly become outdated and inconsistent with the actual code, rather than being a living documentation of the system. And inconsistent and outdated diagrams can often lead to misunderstandings and errors. Then let's look at some of the common challenges due to this manual diagramming methods. You can't really version control PNGs, right? You can't find out who changed the PNG last time, or if you want to restore the PNG or any proprietary software format to a previous version, then it's really hard to track that. And this makes reviewing and auditing the changes in the diagram even more difficult. This compounds into being hard to maintain and scale. As your system grows from being a handful of services to dozens or even hundreds of services, manually updating every affected diagram becomes an insurmountable burden. This often leads to the teams abandoning diagrams altogether, losing on that vital visual communication. Finally, traditional methods lead to poor collaboration. Imagine trying to merge changes into an SVG file. If 3 of your team members have changed an SVG file, can you really merge that? Probably yes, but it would be a complex job. It's a nightmare. It creates workflow bottlenecks and frustration, pushing diagrams to be seen as additional documentation burden rather than an integrated part of the development. These challenges clearly highlight the need for a better way. And that better way for us is diagrams as a code. Because we all are engineers, we write code day to day. So it's easy for us to write code rather than creating pictures. This brings us to the first major paradigm shift in architectural diagramming, diagram as a code 1.0. The core approach here is simple yet revolutionary. Instead of drawing diagrams manually with a mouse, you create them using a domain-specific language, DSL, or actually in the code. The mechanism is straightforward. You write a descriptive text file, much like you write your code, and then a dedicated tool that reads this textual description and converts it into an image format like PNG or SVG. Think of it like writing an HTML web page and then rendering it into browser as a web page, right? If you had to design the web page manually in and some kind of image editor, that would be immensely tedious task or complex task. The fundamental change immediately address many of the frustrations we discussed earlier in traditional diagramming challenges. The core advantages that it brought are profound. First one is version control. Since your diagrams are now stored in code as text files, you can easily version control them using version management software like Git, right? You can also, since your diagrams are now stored in Git, you can easily review them, you can easily track the changes, you can audit, you can have code reviews in place for those diagrams. Second one is automation. Again, because as your diagrams are in text format, you can easily integrate those into your CI/CD pipelines. So you can even write some code or a script to generate your architecture diagrams as part of your CI/CD pipeline. Every time someone commits code, it can trigger a CI/CD pipeline that generates the visual image from that code, and that way your architecture diagram would always be updated and consistent. Third one is consistency. So in text file, you can create common components that can be used across all of your diagrams. So that way, it's easier to maintain consistency across all of your diagrams than it would be to have like a visual component that is embedded into all of the images, right? This supports the mantra that I told earlier of consistency. And the last part is collaboration. If your team wants to create pull requests for changes in the diagrams, sure, you can easily review them. You can have a standardized code review process in place to review the changes to the architecture diagram, and then control how people are updating that architecture diagram. So this makes it more of a collaborative approach, right? Rather than just reviewing the images and then you need to figure out, okay, what changed in this version and the later version, even if you version them. And then some of the early tools that really paved the way for 1.0 approach are and demonstrate the immense power of diagram as code 1.0 are Plant UML, Mermaid, and GraphWiz. So this is an example diagram showing how diagram as code 1.0 looks like on the left side. So you have a user, and then it represents various interactions between the system, how those components are present. And then on the right side, you have another diagram as code 1.0 image, but that has a challenge that in diagram as code 1.0. Anyone can guess like what's the challenge with diagram as code 1.2 from the right image? Okay, so if you see first in the first diagram in Spring Pet Clinic system context, a clinic employee is a user is represented as clinic employee, while in another diagram it is represented as clinic staff. So that if you are creating multiple diagrams, then there is no consistency between those diagrams. If you need to represent a clinic employee, then it should be represented as a single entity across all of your diagrams, so that people don't get confused and they don't consider clinic staff as separate from the clinic employee. And diagram as a code specifically solves this particular challenge. While diagram as a code 1.0 was a significant leap forward, the concept has continued to evolve. This brings us to diagram as code 2.0, a term which is heavily influenced by Simon Brown, who is also the creator of C4 model. He succinctly puts diagram as code is about treating your diagrams as a code rather than just pictures. But 2.0 takes this idea much further. It's about maintaining your architecture, not just drawing pictures. The shift from 1.0 to 2.0 is primarily a shift describing visual elements to defining a conceptual architectural model. The goal of 2.0 is to create actionable integrated diagrams, living blueprints that are directly tied to your code base, driving understanding and decisions rather than just documenting them. Let's dive into some of the key characteristics that defines diagram as a code 2.0. First one is models. At its heart, 2.0 is about defining your software architecture as an explicit model. This means capturing the elements and relationships of your system as data. This typically uses a workspace-based approach. So you can create a workspace where you can have all of your models into a single workspace. And then that workspace can be for one organization or one project. So this typically uses workspace-based approach where your entire architectural model resides in a single coherent place. This promotes a truly single source of truth for your system's design. Next is the multi-view generation. From the single architectural model, 2.0 allows you to create various views of the architecture diagram that can be presented to various stakeholders. Like for non-developers, you can create a separate view. For developers, you can create a separate view that dives into technical details. So based on the requirement, your architecture diagrams can be customized as per your audience needs. Then one good thing about Diagram as Code 2.0 is it also supports the scripting. So there are tools like Structurizer that allow you to automate the whole process and then integrate it into CI/CD. They offer API-driven capabilities and strong support for scripting, allowing you to integrate them not only deeply within your code or other tools. And you can also generate a documentation, a full-fledged documentation from your Diagram as Code 2.0 diagrams. You can programmatically interact with it. So there is Structurizer CLI that is also available that you can use to create and interact with Diagram as Code 2.0. Looking at the future, there's a potential for code synchronization as well. Imagine your architectural model helping to scaffold new services or update the existing configuration files directly. This truly bridges the gap between design and implementation, making diagrams as active part of your development workflow. A prime example of 2.0 tool that embodies these principles is explicitly built around the C4 model is Structurizer, which is developed by Simon Brown himself, who coined this idea of diagram as a code and also is a developer and maintainer for Structurizer, and it's an open source tool. As we just discussed, a core aspect of Diagram as a Code 2.0 is the embracing of strong architectural model. And one of the prominent is C4 model for software architecture created by Simon Brown himself. Now let's take a look at what is C4 model. It's a simple hierarchical approach to visualizing software architecture. The C4 stands for context, containers, components, and code, with each level progressively adding more details than the last. Now why do we need a C4 model? Its power lies in the ability to provide progressive levels of details. This makes it incredibly versatile, suitable for different audiences. You can present a high-level view of the diagram to your non-technical stakeholders and then drill down into technical details for developers, and all from a single consistent model. Let's briefly look at the levels of C4 architecture. At the first level, we have system context diagram, where you map out the entire, like 1,000-foot view of your system. You include your users, your system, and any other systems that it directly interacts with. Think of this as viewing your house on a Google map, right? You will only get a view of your house, nothing deeper than that. But this helps for non-technical folks where you just want to present them the overall understanding of the system. It can also help for new developers to understand what the system looks like. Second level is the containers. In containers, you drill down into specific services that can be individually identified as containers. So it can be a mobile app, it can be a web app, it can be your databases, or even it can be your serverless functions. So all of this can be categorized into containers. Excuse me. So building onto the analogy of finding your house on Google Map, containers would be the blueprint or architectural blueprint of your house. It would include various rooms that are inside your house. The next one is the components. So here you take an individual component and break it down into individual container and break it down into components. So this can be, if you want to continue on the same analogy, this can be, let's say, your house has a kitchen, and then you are dividing it into various appliances that are available in your kitchen. So that is components diagram. The major focus of this component diagram is on the interfaces. And finally, at level 4 is the code diagram. This is the lowest level of detail where you have actual code present. And this is where your developers would be actually more interested in. And this level is, it gives you the overview of what technology stack is used. So the benefits of C4 model are immense. It brings clarity, consistency, and common understanding across the team. By providing a structured way to progressingly reveal detail, it helps prevent information overload. And crucially, it's directly supported and encouraged by 2.0 tools like Structurizer, making it highly actionable with diagrams as a code. And for the last part, we will take at some of the common tools that are available for creating diagrams as a code. With the principles of diagram as code and C4 model in mind, let's take a look at the comparison between some tools. So first one is PlantUML, second one is Mermaid, and third one is Structurizer. Each tool has some capabilities, and there is no one solution fits all for your teams or projects. So you need to make the conscious choice of which tool you want to go for, and what are your requirements for creating the architecture diagrams. So if you take a look at PlantUML, this is somewhat of a veteran in the text to diagram space. The primary focus of general purpose diagramming, supporting a wide array of UML diagrams and even other diagrams like Gantt charts. The syntax is intuitive and text based. And PlantUML also has an excellent integration with some of the leading IDEs like VS Code. So although it's not a diagram as code 2.0 tool, but it has like automation and versioning capabilities that makes it an impressive choice for creating architecture diagrams. It's best for quickly creating various UML diagrams when you need a versatile tool without having a strict architectural model. Then we will take a look at Mermaid.js, or Mermaid as it is known. Mermaid is basically more famous in web-based context. It has support for Markdown, and it also has good integration with IDEs, also with GitHub, GitLab, and so for PlantUML you also have support in Confluence. For Mermaid, you have integration with GitHub, GitLab, VS Code, and other JavaScript libraries. It supports flowcharts, sequence diagrams, and Mermaid is excellent for quickly embedding diagrams directly into your web documentation. It's best for web-based documentation and quick, lightweight diagrams, especially if you are already in Markdown ecosystem. Finally, we have Structurizer. As we have discussed, Structurizer is epitome of 2.0 tool. Explicitly built around the C4 model. Its focus is on modeling your entire software architecture within the workspace. It uses a DSL, so there is a custom DSL for Structurizer that you need to use, and it's open source. And it's specifically designed for C4. Structurizer also provides a strong integration with standalone CLI, and API, or web frontend. Its diagram types are strictly aligned with the C4 levels. So like as we went through earlier, it provides support for C4 model, so you can create the context diagram, component diagram, container diagram, and the code diagram. So it's a workspace-based, API-driven, geared towards actionable diagrams, and provides a single source of truth for your architectural models. Now it's best for teams who are committed to using C4 model, need high consistency, and we want truly actionable diagrams that evolve with complex systems. As I said earlier, the best tools isn't universal. It depends on your team's need, the complexity of your architecture, and your commitment to a structured modeling approach like C4. So yeah, that was it from my side. I'm open for questions. Yes. You have a question? Yep.
I have an interesting question. Is it possible to generate the code from the existing diagram? Let's imagine the case. I have a bunch of thousands or whatever diagrams, and I want to have code from that. Do you have
and those diagrams, are they like images or?
images, photos of images.
Okay. Yeah. So the question here is, I have a bunch of images and I want to create code from those images. Am I understanding that right? Yeah. So I think not with traditional tools that are talked about, but I think it would be definitely possible if you go with an LLM model. And I have specifically tried out Gemini. So it's really good at, you can give it an image and it can generate plant UML. So now you have diagram as code from your image, and then you can start implementing the diagram as a code. So you can use LLM for that. Yeah. Yep. Any more questions? Yes?
Which of the DSLs is the most viable? Because I've been using GraphList for many years, but it seems that now it's not so used anymore. So, which is the way? Is it the erroneous or one ML?
Yeah. So for everyone's understanding, the question is, which of the domain-specific languages is more viable? The user has been using GraphViz for a few years. So I would say, if you want to transition from diagram as code, right? Because GraphViz is a diagram as code 1.0 standard. And if you want to move away from diagramming to modeling your architecture diagrams, right? Where you just create a single model and it's available across all of your diagrams. Whenever you change that, it's reflected across all your diagrams. I would suggest to move towards Structurizer. It's again an open source tool. Really good support for even generating live documentation out of Structurizer DSL diagrams. And it also supports plant UML and other things. Yep. Anything else? Yes?
Have you came across some tool, let's say, that also show you not only the differences between the versions and the code, but also the graphical part? Like if you had some nodes, you see it in the code, but also you would be able to generate the images that would point out which ones are the ones.
So the question here is that, is there any tool available that can view the diff between the images, not only the code part? So for that, you can again go for Structurizer. You can create a custom tool that will, because since your diagram generation part would be integrated into your CI/CD pipeline, you can generate image as part of the CI/CD pipeline, and that can show the diff. So there is no out-of-the-box tool available, but I think it is possible. Like you can write some custom code for that. Any further questions? Okay, and that's it then. Thank you.